Okay, we're going to look at some additional examples to supplement the PowerPoint notes for section 12.2. So if you're asked to find the first partials with respect to x and with respect to y, based upon this given function here, how would you do that? Well, so the first partial with respect to x means that the y variable is held to be a constant. You're going to consider this to be a constant. So what if you just had this? What if you had, let's say, this function in terms of just x? What if you just go back to when we first learned derivatives and you had 2 times x times 4? Well, what would the derivative of this be? What would f prime of x be? Well, if you're just differentiating this with respect to x, the derivative of x is just 1, and the constant part would stay the same. So you just get 2 times 4, or of course 8, all right? So it's the same idea going back and looking at this problem. You're going to hold y squared as a constant when you're differentiating this just with respect to x. So the derivative of x is just 1, so you get 2 times 1 times y squared. This is the first partial derivative with respect to x. Okay, look at this one. What about the first partial with respect to y? Well, now what you're going to do is you're going to hold the other variable, which in this case is x, as a constant. All right, so this is going to remain. Okay, just like, again, if you had something, let's just put it in terms of x again, whatever, just like we did in the past. What if you had 2 times 3 times x squared? Notice I'm breaking this down for a reason because that's what's really going on here. But the fact remains, you do not do anything with the constants. If these constant values, if 6 or 2 times 3 is being multiplied by a variable, then you leave the constants in front when you're looking at the derivative, and all you're doing is differentiating the variable that you're differentiating with respect to. So in this case, the derivative of x squared will be 2x. And again, the biggest thing is leave the constants alone if they're being multiplied by a variable. Okay, so what does that mean? Well, over here, differentiating with respect to y, right here, so that means the 2 and the x stay put, just like the 2 and the 3 did here. Okay, you consider these to be constants. And then what's the derivative of y squared? Well, the derivative of y squared is 2y. So the final answer for this one, the first partial with respect to y, would be 4xy. All right, let's look at a function that is a ratio of two expressions. So I'm going to go ahead and use the quotient rule to come up with a derivative of this, specifically the first partial with respect to x. Let's do that first. So again, I'm going to use the quotient rule. So what is that? Well, you're going to do the bottom or low first, do low, and then d high. And because we're differentiating with respect to x, okay, that does mean we look at the derivative of this high, this top, this numerator. So that's going to be 2x. Okay, and then minus what? Well, high, which is x squared, d low. Okay, the derivative of low, the derivative of the denominator here is just going to be 0 because, again, we're considering this, we're holding y as a constant. We're thinking of this as a constant because we're differentiating with respect to x. So the derivative of this, if this would be a constant, would just be 0. And then the final step would just be low. So that's 8 plus y squared. Now, if you think about this, not that you have to, but if you wanted to, this product would just be 0, so that's gone. And then, so this whole thing's gone now, right? So you're left with just this, the quantity of 8 plus y times 2x, all over the quantity of 8 plus y squared. Well, notice this factor repeats. There's one of them on top and 2 of them on the bottom. So if you really wanted to, you could reduce this and write it as 2x over 8 plus y. This is permissible, but if you wanted to simplify it, this would be the simplification. This is the first partial with respect to x. Okay, now what about with respect to y? Let's see what happens. Well, because we're now looking at the first partial with respect to y, we're differentiating only this, and we're considering the x component here to be just a constant. This is just a number now, because we're differentiating it just with respect to y. So let's go through our quotient rule again. So low, d high. Well, I just said d high, that's going to be the derivative of the top, the numerator, and we're considering this, we're thinking of this as being a constant. So the derivative of a constant, d high, 0. Minus high d low. The d low here, we are able now to come up with the derivative of this. Derivative of 8 is 0. Derivative of y is 1. Okay, so this is d low, the derivative of the denominator. All over again, low, low, or the denominator squared. Okay, so if you wanted to simplify this one, 0 times that is nothing. You just get negative x squared over 8 plus y quantity squared. Okay?